Okay, so that's MLDA Triple E. We're actually one of the student bodies here in NTU Triple E, and our focus is actually in machine learning and data analytics. Okay, so today the speaker will be Charles Wong. He is the CEO and co-founder of Bifrost AI. And then the topic of the sharing will be synthetic data for use in computer vision and how it might soon overtake real data as a reliable way to train models. Okay, so after the sharing session, there will be a Q&A, and then participants can ask questions in this Q&A session, which will last in approximately about approximately 15 minutes. Okay, so there are two ways to actually ask questions during the Q&A session. The first one is to actually just unmute yourself directly and ask questions, and the second one is actually through Slido. So if you don't know what Slido is a online platform for you to ask questions during an event. So the way it works is that you go to slido.com and then enter this event code 20270 or scan this QR code. So later on, after the sharing session, during the 15-minute Q&A, you can actually ask questions. And then the good thing about Slido is you can ask anonymously. So if you're too shy to ask, maybe you can also use Slido for asking questions. Okay, without further ado, I'll pass my time to Charles for the presentation.
Yeah, hey, thanks, Adrian. It's a great intro video from you guys. So what I'm gonna do today is gonna just sort of give a quick overview of synthetic data, about Bifrost, my company, what we do, what we're working on, where we are. And then we're gonna open the floor. I'm not gonna dive into deep technical details from the get-go. I would love for you to ask me anything you're curious about. It doesn't have to be about the company. It can be just AI or synthetic data in general. More than happy to share what I know. Gonna preface that by saying I don't know everything. So if you ask me a question that I'm absolutely stumped by, don't be surprised. I'm gonna share my screen right now. Oh, Andrew, I don't think I have the rights to share screen.
Okay, hold on. Are you the co-host? I think I have made you the co-host.
Yeah.
Okay. Okay, maybe I can try to make you the host and see.
Yeah. Okay.
All right.
Great. No, you know what? I still can't. I still can't share my screen, Edwin.
Oh, okay.
Oh wait, never mind. I can now. Yes, it just appeared.
All right, all right.
Okay, great. All right. Can you guys see my screen?
Yeah, we can see it.
All right, so a quick intro about me. I'm Charles, CEO and co-founder of Bifrost. I used to work on self-driving cars at Autonomy. That's the self-driving car startup that's at One North. They've been acquired a bunch of times. They're called Emotional now, but back then it was called Autonomy. I was on the pioneering autonomous fleet management team, where I helped to build the initial structure for how they were going to manage the autonomous taxis all over Singapore. I used to build race cars in college, Shell Eco Marathon, and later I built a self-driving car prototype SUTD. My co-founder was also from SUTD. He was a computer vision researcher, and he worked at EF startup called Medios, where he developed AI algorithms that outperformed Google. We've been partners in crime on various projects for 5 years now, and in our journey as AI developers, one thing consistently became clear, and that's that building AI requires massive amounts of labeled data. Anyone familiar with deep learning in this call, I'm sure that comes as no surprise to you. But to the extent that it's a problem, obtaining labeled data is the single largest obstacle to building AI. 96% of companies face this problem. The thing is that AI isn't like traditional software. With traditional software, improvements in code can directly lead to a better product. But with AI, it's code and it's improvements in data that give the most returns. But improving a data set isn't always easy, right? Lots of steps. You go to the real world, collect data, curate it, label it, QA, then you have to train and deploy and test. It's a whole like very tedious cycle, right? At Autonomy, where I worked, they used to take one entire year to get all those terabytes of data out of the car, processed, and then into developer hands. So the lead time is absolutely ridiculous. It's no wonder that companies are spending well up to $5 million a year just to label data, and that pain, spawned a $2 billion industry dedicated to labeling data. The thing about the industry is that it's not machines doing the labeling; it's still people, right? It's thousands of crowdsourced workers, right? And that human labor comes at a cost. Scale.com charges $6.40 to label one image for semantic segmentation, which is absolutely crazy. If your data set is a few 100,000 images, you're paying out of your nose for raw human labor, right? And it's not as if the labels that come back are very good either. The labelers are only human. The labels are prone to errors, the low fidelity, lots of quality verification is required. Like if you look at this guy, I think this is from the Coco dataset. The guy on the left obviously doesn't have a pointy head, but well, his segmented body double does, which is when you give this kind of a result to a customer, it's no wonder that they're going to have to go back and forth, and a lot of time is wasted just trying to get this sort of thing right. Labeling sucks, but we think the harder problem is actually data collection, right? It's not just about collecting any old data, right? You need to collect the right kind. If you go out there and film for 12 hours of the street, you may only find interesting or useful data out of 2 of those hours, right? When building AI, you really need a diverse data set. That diversity, that balance is so important to building a robust deep learning model. The problem is that most events are really rare. Like if you want your self-driving car to be resilient to children falling in the street, where are you going to get that data? Are you going to ask child actors to fall in the street in front of you? Unlikely, right? And as a result, data sources tend to be incredibly biased. Lots of samples for just a few kinds of data. Folks in the tech industry call this a long tail problem. And growing that tail, growing those edge cases can be incredibly time consuming and expensive. There's often a cost associated with function. And in 2019, the same thing happened again. Am I still online? Can you hear me?
Hello? Yeah, we can hear you.
Okay.
I think there was a slight disruption there, but
Sure.
now it's
So
fine.
2016, Tesla accident, 2019, exact same accident happened again. Is it because Tesla's engineers are incompetent and they didn't learn from their errors? No, it's because, they just didn't have enough data, the right kind of data. They didn't have enough specific examples of a white truck on a sunny day compensating for the glare, things like that. And that brings us back to the problem, right? AI requires massive amounts of labeled data. Or more accurately, robust AI requires massive amounts of diverse labeled data. Takes months to build a really robust, diverse data set. And that's why my co-founder and I built Bifrost. We wanted to make sure developers could build robust, diverse data sets in hours, not months. We're taking all these processes, collection, curation, labeling, QA, and just boiling it down, replacing it all with Bifrost. Now, how do we do that? It's using synthetic data, right? Instead of collecting data from the real world, we generate diverse 3D worlds from which we can extract synthetic data, basically images, right? With pixel perfect labels at scale. This is an example of a city. We're doing some applications in satellite imagery right now. And a similar example in a maritime context from a drone perspective, right? On the left is a 3D mesh of a scene. On the right is a fully synthetic image. Everything you're seeing so far is fake. It's not real. It's all synthetic imagery. Again, to press home the point, nice thing about synthetic data is that you never have to label the data. Synthetic image on the left and a perfectly labeled image on the right. Because it's automatically labeled, it's labeled, using a script. Everything, all the granular information is captured. Every person, antenna, tower, aircraft. You can't get that kind of detail or pixel precision with a human labeler. Just side-by-side comparison to the poor guy with the pointy head. You can see how much more precise a synthetic label is, right? You don't want to waste engineers' time on quality verification You want them to focus on building quality models instead. Practically, how does our tool look like? It's an API, right? Users select the type of scene and environment they want. In this case, the port in the evening. The objects they're interested in, aircraft carrier, fighter jets, and then the sensor they want to use. So in this case, this satellite sensor is something we're working on with the client right now. And from this base set of parameters, you can cater to tons of different customers, right? Maxar, they're the world's largest imaging satellite company. They wanted this exact use case. They wanted 10,000 images of military vessels in the sea. And another customer, Israel Aerospace Industries, wanted something similar, but this time from a drone perspective. So this time, for us, it's just a simple variable change, a shift in the camera, a change in the sensor properties, right? And then they said they wanted commercial, civilian vessels as well. So it became oil tankers, boats, fishing boats, yachts, that sort of thing, right? And the way we're positioning that is all in a single API. One line of code, parameters all built in. From that, users can generate an enormous, diverse set of images, and this so far has helped our customers achieve over 95% accuracy in real-world testing. High level, how it works. Step one, procedural generation. We take in the parameters that the user sends us through the API, and we generate the environment, the terrain, the trees, the ships, the different objects. And then we use a physically based graphics engine to create accurate, realistic images. So ray tracing, physically based rendering, having the light bounce realistically, realistic textures. Those are all things that we're including in our stack. And finally, we extract those rich labels, pixel perfect labels that developers need, right? So the most common question we get is, how well does it work? It's fake images, it's artificial. How can it possibly replace real imagery? So my co-founder and I went head to head. Right? The task was to detect drones in these images. You can see some of these drones are pretty hard to see, right? Overexposure, underexposure, camouflage with the environment. But we went head to head. I collected a data set of real open source images, like on the left. My co-founder generated his own set of synthetic images on the right. And these are the results. Well, I lost, basically. I only got a 48% accuracy, while synthetic data managed to achieve a 95% accuracy. But maybe more interesting was the time it took, right? For the author to collect the open source data set took him 3 months. But for us to generate, train, and deploy, it was only 4 hours, right? And I'm not saying that real data can't achieve 95% accuracy. Of course it can, but it would just take so much longer to get there. Worth bearing in mind that the benchmarks were all tested on real data, another open source data set, and these are just some examples of the results of the synthetically trained set. Now, synthetic data has a wide range of applications, but right now we're most excited about geospatial analytics, right? It's satellite imagery, it's ship detection, aircraft detection, urban planning, things like that. The market is big, and these are just some of the customers that we're working with at the moment. Earlier, I mentioned in Israel Aerospace Industries, we're helping them with detecting illegal vessels at sea. We're also working with Orbital Insights, one of the world's leading geospatial analytics companies for tracking cargo vehicles. This is what that looks like, right? We're generating a 3D city, we're placing vehicles on the highway, we're extracting pixel perfect labels, where even things like bounding boxes as well, and time series, right? We can have the vehicles move along sort of on a track on the road because we have the road data, and we can just put those 3D models on rails. We're also working with Maxar, a satellite company, to generate synthetic data sets for new satellites. So, a current generation of satellites produce images that look a certain way. Next gen will follow different orbital paths, different times of day, different sensor properties, and we're going to be simulating those new satellites as well. We're also working with NASA JPL, developing synthetic Martian terrain for their new Mars Science helicopter. So in 2021, they're going to launch a full-size Mars helicopter into space. And one of the hardest things that helicopter has to do is learn how to land safely. So we're basically creating a synthetic Martian terrain that's, with everything labeled, sand, gravel, slopes, all that good stuff. And that's going to serve as the ground truth to teach the helicopter how to land safely. We've also done work in other industries as well. We've proven applications in industrial inspection with Rolls-Royce, SMRT, ST Engineering, and even smart retail for F&M. So maybe something that might be interesting to you guys. We just launched this app called Bifrost Data Search. It's basically what we did was we aggregated, analyzed, and tagged almost 2,000 image data sets. Hold on. 2,000 image data sets, made them easily searchable. So it's search by tag, search by class, search by name, author, academic institution. And we just launched it 2 weeks ago. It went down really well. Launched it on Product Hunt, Hacker News, all the usual places. It's a thriving app now. We're always adding new data sets, always adding new features. Eventually, what we want to offer is that, let's say you're a researcher doing prototyping a traffic cone data set, right? You want to build a traffic cone detector. You go in here, you search traffic cones, you find it, and then there's a button to open in Jupyter Notebook. So it chucks you into a Jupyter Notebook with TensorFlow loaded up, with a YOLO V3 detection model loaded up, and then the data set already imported. So you just run, and then you already have a prototype ready to go. I mean, what we're trying to do here is just create like a community, a super easy to use tool for the community to rally around. Commercial, from a business perspective, we want Bifrost to be a beacon for image data for developers like yourselves, like myself, and folks everywhere like that. We're backed by a really awesome team of mentors and advisors from places like NASA, Maxar, Google. Super grateful to be backed by them, helping us enormously with customer development and technology. So that's where we are, but what's next, right? Where do we want to go? Currently, what we're really good at is generating 3D worlds. And we've just found that, producing synthetic images for supervised learning is one of the fastest ways to market, is the most effective use of this technology. But really, the applications go beyond just that, right? It's gaming. When as a 3D artist, you want to quickly create a 3D world for your film or your movie or your video game. You don't want to have to manually place every object. You want to start from a strong foundation. So if one day you want to say, hey, Bifrost.generate Singapore downtown, and then generates an environment that uses Singaporean assets, the stop signs, the traffic lights, the road markings, the buildings. And suddenly you can have GTA Singapore, right? In a matter of hours instead of the 6 years it took them to develop GTA. And also unsupervised learning. So this is maybe where it gets interesting, right? I'm presuming that you guys are generally familiar with reinforcement learning as a concept. Reinforcement learning is basically where instead of feeding an AI model lots of pre-labeled data to tell it like this is a car, this is a tree, this is a truck, reinforcement learning is throwing the AI model into a sandbox environment and asking it to learn itself. Right? It's the equivalent of throwing a baby into a playground and asking it to learn and grow up and experiment for itself, rather than feeding the baby lots of assessment books. The thing there is that as unsupervised learning, as reinforcement learning becomes more effective, more powerful, more mainstream, the current data, the supervised data training images will no longer be the currency of the AI world. It will be 3D environments, right? Like OpenAI built the incredible reinforcement learning model, which defeated world champions in Dota. And the way they did that was, Dota is a sandbox environment. It's a very complex game, but it's still a game with well-defined rules. If you want to take OpenAI's work and apply it to the real world, you need a virtual environment that's as reflective of the real world. And if Rockstar Games takes 6 years to develop GTA, I don't think you want to wait 6 years every time you want to build a new AI model. I think you want to generate it automatically instead. So that's where we want to go. So yeah, that's us. That's where we are. I'm happy to take questions. In fact, I think that's the best way for me to find out what you guys want to know. So fire away, feel free.
Okay, thank you so much, Charles, for the insightful sharing. So right now we're going to conduct the Q&A session. So if any of you have questions, you can just unmute yourself right now and ask questions to Charles. Or you can also go to Slido with event code 20270. I put it in the chat. I put it in the chat there. So you can start asking now. Any questions?
It doesn't have to be just about synthetic data. If you guys want to, Andrew, are these mostly undergrads in the call?
Yeah, it's mostly undergrads. But
Cool. I
yesterday
mean,
we
if you
do
want
have.
to, I didn't graduate that long ago. If you want to ask me things about uni or career, your first jobs or about startups in general, feel free. Right? It doesn't just have to be about machine learning and synthetic data. I see a question about do synthetic data sets run into overfitting issues? Depends. If you're referring to it overfitting to a synthetic environment, that's quite easily avoidable. You can mix in your synthetic data set with a real data set. Synthetic, you can, chuck in lots of distractors, different environments, different lighting change, different lighting variations into your synthetic environment, and that avoids a lot of general overfitting. In fact, synthetic data addresses overfitting really well because often it's the real data that's hard to expand, right? And that's where you often run into overfitting. And synthetic data just gives you an easy way to expand your environment set, expand your variable set very, very easily. For example, for the job we were doing with SMRT, they were trying to do graffiti detection on trains. So they had a very, very small data set of graffiti because how often do SMRT trains get vandalized? They tried a whole bunch of things like sticking stickers onto trains, but the model just kept overfitting because the data set was just so tiny. I think that's where synthetic data really shines, right? Where data is difficult to get or rare or sometimes impossible. That's where synthetic data really comes in and sort of just enables new capabilities that just were not possible before. Yeah. I see another question on synthetic data sets perform against test cases which are noisy. Could you elaborate? Whoever wrote that in the chat, do you just mind unmuting yourself and just letting me know what you mean by noisy? Anybody?
Okay, perhaps he's writing down any comments there.
In the event that since I don't really fully understand the question, I'll give it my best shot. If I assume test cases which are noisy, I don't know if you mean sensor noise, like the camera is like ISO setting very high, it's very noisy, grainy image, or you mean test cases which are all over the place with like weird distractors, different sensor types is very fragmented. Um, the synthetic data, it's not easy to, you can't just paint synthetic data sets with one stroke and say that, oh, synthetic data will always perform better in noisy situations or non-noisy situations. Because synthetic data, you control the synthetic data set, you control every parameter, right? If you want to build in the variation, the quote-unquote noise, you absolutely can. It's up to you to build the synthetic data sets which resemble the distribution of your real-world deployment.
Okay, apparently the noise is, it means some kind of grainy image or misplaced object.
I see. Yeah, grainy images is a perfect use for synthetic data, right? Because you can simulate that noise using a. So what we do at Bifrost specifically is that we simulate the sensor properties whenever we take a picture, right? We're not just using a default camera. We're always like, if the image was taken from a drone camera or from a GoPro, right? We will simulate the focal length, the curvature, the curvature of the image, the the sensor noise. Like often, industrial cameras will have a noise rating in the spec sheet, and those are things we can add and layer over the image. So that really, really helps on a pixel level with generalizability.
Okay, I think there's another question. So
Yeah.
how do you think COVID will change the course of AI industry? Will COVID accelerate AI adoption or the other way around?
Tough call, man. I mean, I'm not a medical expert. It's tough for me to say. I think I think COVID is accelerating all technology adoption as a whole. Tough to say about, specifically about AI, right? I mean, all the, like how we're doing this now, right? Ordinarily, we will all pile into our auditorium somewhere. I would have to haul my ass all the way to Pulau NTU and share, give this sharing session with you. But now it's all done through Zoom or it's perfectly normal to do this on stories of AI. Oh, can you hear me?
Hello? Yeah.
Yeah.
I think there was a slight disruption just now.
Sure. I was saying I think I see kind of two opposing narratives with AI, right? One is that um, COVID is speeding up adoption because the demand for new tech solutions like those face detection, temperature detection things at malls are getting in hot demand. Governments paying top dollar for it. Um, we're also seeing like activities that people would do, like let's say ST engineering wants to collect a drone data set and they go fly drones around, but in quarantine, who's going to fly the drones? How many team members can you deploy to fly the drones? How many public areas are you allowed to access while in quarantine? Suddenly synthetic data looks like a much more attractive prospect. So that's one narrative. The other narrative is that um, you know COVID is just dropping productivity, right?
Yeah.
Which can mean that AI is being developed slower, but it can also mean that employers are finding more reasons for AI to exist to replace the lost productivity. I don't know. I can't. Those are all opposing stories. I can't give you a general answer, to be honest.
Okay, if you still have questions, you can also ask. We still have a few minutes here for the Q&A session. Okay, maybe I can ask you a question.
Yeah.
So, it's more about your experience. Like, what really motivates you to create this synthetic data set, to create Bifrost? Is it your experience in working in autonomy, perhaps?
I think that was the spark. It was where it gave me a lot. It gave me myself a lot of ideas, and it just corroborated with the ideas that my co-founder had while working in his own AI on his own AI activities. Right? Um, Depends. There are two questions there, right? Why synthetic data and why did I start a startup?
Yeah.
Because I could have easily gone the academic route and done synthetic data as my thesis instead. Um, Why synthetic data? I think for the reasons I've already mentioned. It sucks. It's a problem. But as to why start a startup, it's something I've always wanted to do. I think that a startup is one of the most efficient vehicles to drive impact for a certain idea.
Okay.
Academia is great. Don't get me wrong. But often, first there's the R&D of the idea, and then there's a transition from R&D into commercial. I think that a startup as a product development research vehicle is a much more efficient way to put things together than a research lab. Um, I think the feedback loop for validation is immediate because people either want to pay you money or don't want to pay you. You're not hunting for grants from universities or hunting for grants from National Science Foundation because government has a directive for more AI stuff. You are talking to a company who is in dire need for computer vision. You're talking to someone like NASA who wants to launch a helicopter but is scared to land it because they don't have enough data. That's the truest form of validation that um, the idea you have as merit, right? Talking to real paying users. So for me, uh, yeah, it was just the most effective way for me to drive impact from where I am. And I got a preface, right? Where we the startup is literally myself and my co-founder in our bedrooms. We have some interns, of course, right? But given COVID, we're just two guys in our bedrooms. Um, Obviously, we have an amazing support from mentors and advisors, investors, and things like that. But ultimately, we're just two guys in our bedrooms, right? So don't let that stop you from trying something out like this. If we can do it, you can definitely do it. So
Oh, that's really nice. Oh, okay. There's another question there. So what was the startup process like?
Well, that's a big question. You wanna elaborate a little? Which portion of the startup process? You can chat in Zoom if the slider is a bit too slow. Inception. Wow. Well, here's the thing. I think so. We're all engineers or scientists in this group, right? So I think the tendency for us is to want to build something really cool and then see how we can like make it a product. But often we have it the wrong way around. We need to find someone who needs it first. We need to find a problem first and then build something for it. So SMRT was our very first customer, and I'll be honest, when we were getting SMRT on board as a pilot customer, we did not have a real product. We basically um, use our put together some 3D images, called it concepts. Gave a presentation to SMRT and gauge whether they wanted it or not. And then they signed it, and then suddenly, oh, we got our work cut out for us. Now we have to build an actual data pipeline to service them, right? And while that sounds very haphazard, it sounds like can feel quite disingenuous as an engineer. Um, it is like 90% of the time, engineers and scientists who start companies often start with a solution first, and that's such an easy mistake to make. Validation from users comes first for sure, and maybe it doesn't mean that you have to actually close a contract with someone like SMRT. It can mean going out doing your surveys. It can mean talking to people. It can mean interning somewhere and then realizing that internally at the company there are a lot of issues, right? Validation can come from many sources, but make sure you validate the problem first before you start jumping to building. If you just want to build because it's cool and exciting and innovative, then being a DIY enthusiast or a researcher might be more fitting to what you want to do.
Okay, I think we can have one more question. If anybody still has question, then you can also ask here.
All right.
All right. I think that's it. Okay. So that's the sharing session. Thank you very much, Charles. Okay. Before we end, I think it's great for us to take a group photo. So everybody, if you can, please turn on your camera so we can take a screenshot. Okay,
Well,
are your cameras working?
okay, anyway, before everyone leaves out of shame of showing their horrible bedrooms, please, I dropped my email in the chat. If you have any questions or you just want to talk about stuff, feel free to drop me an email. I may not answer immediately, but I'll do my best.
Okay, hello, Philip.
Appreciate it, guys.
Hello, Ishan.
All right, why don't we just go for it?
Okay, I'll take the screenshot now. Okay, 1, 2, 3. Okay. Yeah, that's it, guys. Thank you very much.
I have a question. Is MLDA made mostly of guys?
Pardon?
Is MLDA consisting mostly of guys?
Sorry, I didn't hear that clearly.
Is MLDA consisting mostly of guys?
Oh, um, not really sure, but we do have some women also. Yeah.
All right. Speaking from someone who used to run a very, because I used to run an electric vehicle club at SUT, like electrical team, right? We made the mistake of, because cars, right? So it tends to attract guys a lot. We made the mistake of not doing more to attract more diverse people into our group. So I recommend making that effort, even if it seems a little unnatural and forced sometimes.
Okay, by the way, can you make me the host again? I'm going to share the slide.
You what, sorry?
Can you make me the host again?
Oh,
I need to
oh,
share
I
the
didn't, I
slide.
didn't
Yeah,
realize you lost.
yeah. I think there's a setting by the admin that disables
Right,
everyone to share. All right, thank you. Okay, so before we go, this is MLDA's social sites, and there's YouTube, there's Facebook, LinkedIn, Instagram. You can scan this QR code or go to this website to check out our social media. Okay, in case you're interested.
Cool.
Okay, moving on. So I believe that's the end of our session today. Please, if you have time, you can fill in this feedback form here. Your feedback will be much appreciated. And that's all for today's session. Oh, and also this video will be uploaded to YouTube. So in case you have a friend who says that he or she cannot attend due to some maybe morning lessons, you can ask him or her to go to our YouTube page, and this video will be available there. Okay, so that's the end of our session today. Thank you guys for coming. Don't forget to check out our LinkedIn and other social media pages as well.
All right. Thanks, guys.
Okay, thank you guys so much. Thanks, Charles.
All right. Appreciate it.
Okay,
Stopping by.
those of you who are still here, you can fill in the feedback form here. Otherwise, you can already dismiss. Yeah, thank you.